In this lesson, we will be exploring triangles. So things that we know from previous units is, so we can use a ruler to measure the side lengths of a triangle. We can use a protractor to measure the angles in a triangle. And we can fold a triangle or use a mirror to find the lines of symmetry in a triangle. So just a quick recap on symmetry. Symmetry is when you have a line that you can fold the shape on and it lines up perfectly. So my demonstration or example is if I have this heart, I can draw a line on my heart right here. Oh, it's not a line. There we go. I can draw a line right here, and I'm just gonna have to move it for a second. And if I fold my heart over that line, it's going to line up exactly. So that is symmetry. So when we can fold it in half and it lines up exactly. Now the mirror boards are those red boards that we use, and you can see through them, but they create a bit of a reflection in them. We can use those to find symmetry as well. We're not going to talk about them though, because I don't think many of you have a mirror board at home. So we can use attributes, or attributes would be characteristics or the looks and the different descriptions of things to sort triangles. So we can name triangles according to their side lengths and compare. So previously we had talked about different types of angles. These are different types of triangles. So an equilateral triangle has 3 equal sides. So all 3 sides have the exact same length. An isosceles triangle has 2 equal sides. And a scalene triangle has no equal sides. So all 3 sides are a different length. Now you can see we have these little, we call them hatch marks. We use those to show us that those are the same length. So when I have 1 hatch mark, it means that all lines that have that 1 line through it all are the same measurement. In this case, I have 2 and 2. So that means that this side and this side are the same. And here I don't have any. So that means that I have no equal sides. Some other attributes of triangles. So an equilateral triangle has 3 equal angles and 3 lines of symmetry. So all 3 angles in an equilateral triangle will all be 60 degrees. And you can see that in this triangle, we have used 1 curve in the corner. And so those marching arcs is the word that we use for them, show that they're the same angle. So if I had a different angle, I could have maybe one that has 1 arc and one that has a double arc, kind of like we have a double hatch up there. We also have 3 lines of symmetry, so I can go through any one of those points and I'm going to create a line of symmetry that I can fold and my triangle will line up with itself. So since the sum of the angles in a triangle is 180 degrees, and we learned that last week, each angle measure is 180 divided by 3 because we have 3 angles there, so 60 degrees. So all equilateral triangles have angle measures of 60 degrees, and whatever their side length is, they're all the same. An isosceles triangle has 2 equal angles and 1 line of symmetry. So an isosceles triangle will have 2 side lengths that are the same, and at the bottom of those 2 side lengths, we are going to have 2 equal angles. The other thing we'll have is through the unequal angle, the off one, a line of symmetry through there. So it'll come from the top down. So whichever is not our equal sides, they will create a point and our line of symmetry will go through the middle. A scalene triangle has no equal angles and no lines of symmetry. So that means there's no way that I could fold this shape in half and it would line up. All of my angles are different. All of my sides are different. So in this assignment, I'm going to ask you to go through and name each triangle, isosceles, equilateral, or scalene, and explore a little. So you might want to take some of these triangles and draw some, or maybe trace them off the book, or maybe print an extra copy, or trace them off your computer screen and cut them out and try the lines of symmetry. Take your protractor, try measuring them and see what it looks like. Some of them you can tell by looking at them. Some of them are a little bit trickier. So have some fun, do a little bit of exploration with this, and we will continue our learning with triangles next time round.